Hi guys. Today I'd like to demonstrate for you in detail a somewhat challenging example from chapter 8, number 10. So let's go to this is a chapter on regression analysis, and we're going to be doing example number 10, which is an example of multiple regression, and it has three complications that we have to go through carefully. First of all, it's a step up from earlier examples in the chapter called simple linear regression, which involves trying to predict a variable based on another variable. The variable we're trying to predict is called the dependent variable. But now we're going to have two variables. In fact, later on we're going to have more than one variable to try to predict a linear relationship between the x, which is the independent variable, and the y, which is the single dependent variable. So let's jump into it. So here's the data, and we're trying to see if the lot cost, in other words, the real estate itself, can predict the sales price. Obviously, there's a connection between the real estate and the sales price, but they're also taking into account now the type of house that we're dealing with, either a townhouse or a single family house, which are generally more expensive. So um, the second complication, after the complication that we're dealing with multiple variables, and therefore multiple linear regression, is that the second variable is not a number. Our formulas are developed to look at the impact of a number on another number. But here we have a category. So the solution is to change it into a number by using the concept of dummy variables. And you basically have to decide to call arbitrarily one variable a one. Let's say a townhouse equals one means it's a townhouse. And if it's equal to zero, it means it's a single family house. Notice that we have two categories here, so a single dummy variable will work. But if we had three categories, I think the book discusses this, you would need, I'm not sure if there's any homework involving that or therefore no test questions, but there is the possibility of more than two categories, in which case you would need more than one dummy variable to specify a numerical value for those categorical variables. And the third complication is, and this will be introduced in the middle of the problem, is that the question is, in addition to looking at the impact of these two variables on type and lot cost on the sales price, we want to investigate the possibility of interaction. And that means how two variables interact or affect each other in affecting the price. So for example, it's very possible that lot cost has an impact on sales price all across the board. For townhouses and single family houses, it's exactly the same. The other possibility is that lot cost has no relationship. And a third possibility is that lot cost only has a relationship for townhouses. But for single family houses, it's not going to be true, or vice versa. It only has an impact for single family houses, but not for town. Now, that could be teased out by looking at the interaction between these two variables and their impact on sales price. And it sounds complicated, but in fact, it's very simple. All you do is you multiply the two variables that you want to see if they have an impact, an interaction impact on sales price. Now we're going to see this all in a second. First, we're going to get the data into Excel, which is here. Then we're going to Um, let's see. So we want to see, I'm going to move this column because I like to see let's put it over here. Okay. And we mentioned that we have to change townhouse into a numerical, so let's call it, instead of type of house, let's call it type underscore n, meaning it's a number. Now we can put down 1, 0, 1, 0, 1, 1, but you can do this much easily and more easily in Excel by using the function. The if function, if parenthesis, and the variable we're looking at right now is A2. If A2 is equal to the text townhouse, of course you have to be very careful about capitals, close quote, then call that a 1. Otherwise, make it a 0. It worked. Okay, and then we can drag this down, and we have the 1s and 0s that we need. Now we're ready to do the, oh, maybe we should look at the question. I'm sorry. Here's the question. We don't need the data anymore. Develop a multiple regression equation, basically seeing how these two variables, lot cost and townhouse, there's always going to be an intercept or a constant at the beginning of these linear, multiple linear regression equations. Okay, so let's do it. Go back to Excel. We go to data analysis, which comes from, I hope you had it by now. You added on the data analysis pack. You get it by, I should take a digression here, and shows you go to file, options, and then you go to add-ins, and you ask for this analysis data pack. Okay. Anyway, we're going to data analysis. We're doing regression right now, so we have to find regression. Okay, and we have to fill in 3 or 4 things. The input for the y is called a dependent variable, so we just put right down there. We want to have a label. We want to tell the computer the first column is a label. What's the x? The x are these. Whoops. Click in the box, then pull it down. Now we have the x's, and we have to tell the computer where we're going to put the results. So let's output range will be, click on here, and let's put it here. Hit OK, and it produces the results that would have taken us hours by hand. Okay, so how do you interpret this? First of all, if you recall from other parts of the chapter, there's something called R and R squared, which is essentially telling you how close the relationship is. And since this is 0.73, it's probably pretty good. This tells you the significance, the p-value of that relationship. But we want right now the coefficients. Those are the numbers in front of the interceptor stays by itself. So I'll put this over here. Let's copy it. Let's go back to the question. Where'd that question go? Here's the question. So the sales price, the interceptor of this equation was just copied from the here. Then we copy the type of house. Copy. Where'd it go again? Type of house. Remember, townhouse is it's just a name. It could be the 0 or a 1. Goes here. The lot cost, we just sort of got it a little different order than the book had it. You don't have to round it. It used to be you had to round it. Now you don't have to round it. Where are we? Lot cost coefficient is going to be here. Check answer. And we did it. Okay, move on. Determine if an interaction exists. Okay, interaction. Well, you have to create an interaction variable. Let's call it interaction. Of course, you can call it anything you want. It's another independent variable, and it's equal to the product of the column B and column C. So it's going to be B2 times C2 which 1 times 22,000 is that. Pull it down, and now we're ready to continue. Let's do the next regression now, including the interaction term that will tell us if there's a differential effect of lot cost on sales price dependent on the type of house that it is. So let's do it. We're in data analysis, regression we already have. We already have the correct Y column. This now is going to be extended from B to D. So we're going to extend this to D. We still have labels. Now we're going to put the output, let's put it over here. Okay, and now we have our output. And now we have more coefficients. But what we're really looking at is the p-value. If you recall, the book said that the alpha, which is the type 1 error threshold, is 10% or 0.10. 0.09 is slightly less than that. So it is significant. And the rule is once you have a significant interaction, you have to include in the model the components of the interaction, which in this case were type and lot cost. So we're going to we'll use all these coefficients in the final model, but let's ask the question. Let's answer the question. Why is there an interaction? What do we just conclude from that Excel file I just mentioned a second ago? Well, it's part C. An interaction exists because the p-value of the lot cost times tau or put over here. There we go. Check hands. Bluetooth. Hi guys. Sorry about that computer issue, and I said I'll do 2 parts. I think I'm going to continue with 1 part, so you might have to fast forward a few seconds during this interruption. Anyway, what we was just saying was that the interaction does exist because this p-value, I'm going to copy it again, copy, because it exists because the p-value of the lot times the townhouse variable was significant. Oh, no. Oh boy, let's try it again. Copy, paste, Control V. Okay, that wasn't where I wanted it. All right, let's see if that works. Yes, good. Okay, moving along. Now they want you to identify the model. Well, again, we said the model has to include the interaction, which was significant, and therefore the components, even though lot cost was not significant, or townhouse, whatever, and the intercept. So basically, you're going to basically cut and paste the coefficients that we just saw. This is the intercept, copy. This is a little tedious, I have to admit. Control V. And the townhouse by itself, which is a type variable, has this coefficient. Copy, paste. The lot cost has this variable, this coefficient, sorry. And finally, the lot cost times the townhouse interaction variable will be found here under interaction, under the coefficient column, where it meets interaction. Oops. Copy. And Control V, check answer. Oh my God, that worked. Okay, now comes the last part of the problem, using all this information to make a forecast or a prediction. And they want us to know what's it going to cost? Well, what's the sales price predicted to be if we're dealing with a single family home, and then the separate second problem when it's a townhouse, for a single family home, and the number for the lot is 31,000. So basically, again, I'm not going to do this right now, is you substitute for townhouse, remember equals 0, that's a 0, so 0 times this is going to be 0. The lot is 31,200. So you substitute that into this spot over here. You multiply it by 4.27, and you add to it this times the 31,200 times 0. So this thing disappears. So basically, the answer is going to be, actually, let's do it just for the hell of it. It's going to be 4.271 to round it. 4.271. Whoop. 4.271 multiplied by the 31,000, I'm sorry, times the lot cost, which is 31,200, 31,200, and that equals to 133,255, but we have to add on this number here, gets added on, that's the coefficient, so it's going to be plus 76,025.49, and that's equal to 209,000. 209,280.69. If this works, I'd be very surprised. It worked. Then you would do it a second time. You go through the same exercise, but this time you substitute a 1 for townhouse, because now we're talking about a townhouse. which I don't know what the answer is, but I'll let you do that as an exercise. So that's it, guys. I hope this helped you.